Just a quick disclaimer, I have applied for a patent regarding this technology. Hello, I'm Dr. John Cotter. A little over a year ago, I found out that you can make a concrete mix with about 50% rubber by volume that nails like it's wood. As in, you can cut it and install it just like it's a wood board. I decided to partner with the University of South Florida since at the time I was finishing up my PhD at the school. They wanted me to conduct research proving what I was indicating, so I went into development and figured out how to make a reinforced concrete using this mix that allows you to cast concrete boards. These boards are dimensioned like wood boards and can be shipped from a precast concrete plant directly to a job site, retail store, wholesaler, etc. This concrete can also be cast on site if you need it to be. The concrete actually ended up being a little bit better than the wood control we were using in experiments. For example, the concrete holds smooth shank nails up to 25% better, has a design strength 13% better due to failing in a ductile manner, and has 41% less deflection than spruce. These figures allow this concrete to function as a direct replacement for wood. No, these aren't just numbers I pulled from thin air. This is from research we published in a scientific journal. We specifically published in a journal that's open access, so as long as you can go to their website, you can download the paper for free. It describes this nailable concrete, including the specific mix used to create it. The paper is linked in the description of the video. But here's where things get even better. The real advantage of this concrete, as compared to wood, is in applications where wood could rot or be eaten by insects like termites. I live in Florida where you can't leave untreated wood alone without termites starting to eat it. And if you leave it outside and it gets wet, the fungus will start eating it too. So to make wood last longer in wet environments, treated wood was introduced. But some of these treatments aren't the best for the environment. Some of the longer-lasting treatments, like creosote, the EPA will only let a few industries use them, if at all anymore. The more commonly available treated wood, which lasts a decent amount of time, still only typically lasts 10 years in Florida, and contains arsenic. The concrete we're describing here is reinforced, and reinforced concrete typically lasts 50 to 100 years. So what this means that if you were to use one of these concrete beams or posts we're describing here, which you could use in place of treated wood, you'd save as many as 5 to 10 boards worth of arsenic from leaching into the environment. And this can be done while addressing the global tire waste problem. Hundreds of millions of tires are disposed of every year. Recycling tires is one option, but there is limited usage. So I, like many other researchers, are trying to find different ways to reuse these tires. This technology represents an additional method of recycling those tires effectively. Probably the coolest part of the entire technology is that it actually attacks two different environmental problems at once, because we're both preventing arsenic from being released into the environment and addressing the global waste tire problem. But here's the one problem I do have about this concrete. While I can make small sample sizes, I'm pretty limited on how many pieces of concrete I can manufacture in a day. So what I'm doing is I'm trying to find different companies I can partner with that could possibly manufacture this concrete. So if you see this video and you know anybody that would be interested in it, please send it to them so I can try and get a hold of somebody that knows somebody that has a precast concrete plant so we can start manufacturing this stuff and making it available for more and more people to be able to purchase. Thanks again, it's been fun talking to you.